The James Webb Space Telescope has fundamentally provided the most accurate image of Proxima Centauri B to date, offering remarkable insights into a potentially habitable exoplanet. It beckons us to go on a journey through the universe to uncover the mysteries of Proxima and Tauri B, and to examine whether either might be the next Earth. We attempt to explore the vastness of space, where a mysterious planet resides within the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock. Its existence is extraordinary. Proxima Centauri B is located a mere 4.2 light-years away from us, making it the most widely known exoplanet closest to Earth. This planet is shrouded in enigmas and marvels. Could it be a different Earth, with life and oceans flourishing on its surface? However, there's more to the story. Proxima Centauri B's system is not unique. It is accompanied by Tauri C and Proxima itself, all orbiting a red dwarf star, and who knows what other secrets this star system may hold. Perhaps there's another companion yet to be discovered. The intrigue deepens. Proxima Centauri emits approximately the same amount of energy to Proxima B as the Sun does to Earth. Is this really implying that there could be water on its surface, and possibly even life beyond our solar system? We encounter an entirely new realm: exoplanets. These are planets that orbit stars other than the Sun. With an estimated 200 billion stars in the universe, the possibilities for exoplanets are limitless. Some even drift freely through space, unattached to any star, like wandering travelers. In the cosmos, among them all, Proxima Centauri B stands out as an especially captivating and intriguing planet. Its year lasts only 11.2 Earth days, and its proximity to its star is much closer than Earth is to the Sun. Indeed, one side of the planet is perpetually bathed in sunlight, while the opposite side remains in eternal darkness. Let's investigate. Proxima Centauri, the star that Proxima Centauri B orbits. Proxima is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri B. Together, these stars form the closest star system to our solar system. Alpha Centauri A and Alpha Centauri B constitute a binary system, known as Alpha Centauri AB. These G-type and K-type stars appear as a single entity in the Centaurus constellation, and are the third brightest stars in our night sky. With a peak luminosity of under 2.7, Proxima Centauri, also referred to as Alpha Centauri C, is a red dwarf, or M-type, star located 4.2 light-years from the other two stars, approximately 4 times the distance between Earth and the Sun. It holds the distinction of being the closest star to us. The name Proxima means the closest in Latin, and it was discovered in 1915 by Scottish astronomer Robert Innes. Despite being our nearest celestial neighbor, Proxima Centauri is not visible to the naked eye, with an apparent magnitude of 11.13, much dimmer than the human eye's limit of 6.5. Nevertheless, don't let that deceive you. Proxima Centauri is still a red dwarf star worth studying. Stars, like Proxima and Tauri, are among the most efficient in terms of energy production. They may not emit vast amounts of energy, but the internal convection processes at their cores support them for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still up for debate. For one reason, it is a flare star, meaning it experiences frequent and intense stellar explosions. Its habitable zone is significantly closer than the Sun's, projected to be somewhere in the range between 0.23 and 0.54 AU, but it isn't as habitable as it seems. Proxima Centauri B is bombarded by intense ultraviolet radiation from its star, regularly stronger than what Earth receives from the Sun. That's right, it's so extreme that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima Centauri B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, living organisms would be vulnerable to harsh space weather conditions, making life nearly impossible. So, while Proxima Centauri b might appear Earth-like on the surface, it is far from being able to support life. Scientists remain cautious because numerous factors could render it inhospitable. The mission to reveal the truth about Proxima Centauri b continues. One tool that has garnered astronomers' attention is the James Webb Space Telescope. After years of anticipation, the telescope was finally launched in 2018 and is now helping to determine if there is life on Proxima Centauri b on the other hand. As with everything in science, things are never as clear as they seem. Several adjustments were required to guarantee that the James Webb Space Telescope delivers accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima Centauri b can absorb light from its star, it can also emit it as infrared light. The James Webb Space Telescope was specifically designed to detect infrared light. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere does not guarantee that life exists, cautions Ed Turner, an astrophysicist at Princeton University. Proxima Centauri b could be like Venus, with a thick atmosphere much denser than Earth's, and with extreme temperatures that would make life impossible. The journey to unravel the mysteries of Proxima Centauri b is not without its challenges. While the James Webb Space Telescope has potential, many factors must be considered. With costs mounting, space scientists feel the pressure to find ways to observe planets like Proxima Centauri b. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which is what makes it so fascinating, practically like exploring our own backyard. Even more exciting is that it's roughly the same size as Earth, and its position in the habitable zone suggests it could, indeed, have conditions suitable for life. Proxima Centauri b's proximity also makes it an ideal target in our quest for life beyond Earth. With it being so close, it's a prime candidate. For missions to other stars, think about exploring this Earth-like exoplanet. Even though we are unable to visit that location yet, it's certainly on the radar for future missions as technology advances. It's one of the most exciting endeavors in space exploration. However, the journey is anything but simple. For example, it would take approximately 75,000 years for a craft like Voyager 2 to reach the Proxima Centauri system, still operating at its current rate. A potential solution has been proposed: solar sails. These ultra-thin reflective sails could be employed to propel a spacecraft on its way to the Alpha Centauri system, including Proxima Centauri. This technology harnesses radiation pressure from sunlight to maintain its trajectory, eliminating the need for traditional fuel. Even more intriguing, this advanced propulsion method could offer insights into the existence of life on distant worlds like Proxima Centauri b. However, like all bold ideas, there are limitations. For instance, simply having an atmosphere does not always equate to habitability. Proxima Centauri bi might look like Venus, covered in an intensely hot atmosphere that renders the surface uninhabitable. Moreover, the James Webb Space Telescope has the capability to detect emissions even if they amount to only 5% of the brightness of the planet's dayside. That may not sound like much, but considering the dim nature of its host star compared to our Sun, it's quite significant. If Proxima Centauri b harbors advanced civilizations, they might even utilize enormous orbital mirrors to direct sunlight away from the perpetual day side to the dark side. How fascinating is that? The universe contains a large number of waiting exoplanets. The discovery of these celestial bodies covers an immense range of types and sizes, from massive gas giants to Earth-like planets. One intriguing type of exoplanet is the gas giant, similar in composition to Jupiter and Saturn, but often much larger. Some are called super Jupiters, dwarfing even our solar system's largest planets. But that isn't the only type. There are also hot Jupiters, massive gas planets that orbit in close proximity to their host stars, residing in environments so hot they could melt metals. Picture witnessing such a planet up close, with ferocious storms and scorching heat. In addition, to gas giants, there are Neptunian exoplanets, which share similarities with Uranus and Neptune. Mini-Neptunes and hot Neptunes are among these, smaller, more compact versions of their gas giant cousins. These planets are often cloaked in mystery due to the difficulty of analyzing their atmospheres from afar. Let's not overlook Earth-like exoplanets, worlds that closely resemble our own. These planets vary in size, ranging from slightly smaller to over twice the mass of Earth. Among them are super-Earths, which are more massive than our planet, but lighter than ice giants like Neptune. One of the most enthralling exoplanets found in recent times is Proxima Centauri B, which revolves around the star of the same name. It is referred to as a super-Earth, with a mass estimated to be about 7 times that of Earth. Although it lies close to its star, it might still be too far to fall within the traditional boundaries of the habitable zone, and Proxima Centauri B isn't alone. It has a sibling, Proxima Centauri C, which is situated farther out in the system. This planet completes one orbit roughly every 5 Earth years, and was confirmed in 2020 using archival Hubble Space Telescope data. Even more intriguing is the suggestion that Proxima Centauri B may be a planet with a lot of light, potentially due to a ring system reflecting starlight. But the intrigue doesn't end there. In 2019, astronomers noted a peculiar variation in Proxima Centauri's radial velocity, potentially indicating the presence of yet another planet. If verified, this planet would be named Proxima Centauri D and is estimated to be about the size of Mercury or Mars. Envision a night sky that is not only star-studded, but filled with an abundance of alien worlds, each possessing unique properties, climates, and orbital patterns. The cosmos is a treasure trove of surprises, and exoplanets are among the most intriguing. With new exoplanet discoveries being made frequently, it's a thrilling time to be a planetary scientist or astronomer. Although we don't yet know the exact number of exoplanets, it's clear that they are as abundant as the stars themselves. However, these distant worlds present significant challenges. They're often hidden by the brightness of their parent stars, making direct observation extremely difficult. But technological advances have now made it possible to directly image some exoplanets. To achieve this, a planet must be big enough, far enough away from its star, and young and hot enough to glow in infrared. These are all very specific conditions that still restrict our ability to observe. Even these sporadic glimpses have been profoundly enlightening. Most exoplanets are discovered not by direct observation, but by the effect they have on their stars. The gravitational tug of an orbiting planet can cause a star to wobble, a phenomenon known as radial velocity, which astronomers can detect. NASA's Kepler Space Telescope revolutionized this field using the transit method, detecting small dips in starlight as planets pass in front of their stars. This method has given us valuable data on the sizes of planets, orbital distances, and surface temperatures. Here are a couple of intriguing facts. Over 22% of Sun-like stars are believed to host Earth-sized planets in their habitable zones. The TRAPPIST-1 system has 7 rocky planets, several of which may contain liquid water. Just like the moons in our solar system, many exoplanets are likely to have natural satellites, exomoons. With over 4,000 exoplanets confirmed so far, we know they are widespread throughout the galaxy. Hot Jupiters, with their immense mass and close proximity to their stars, remain the easiest to detect. But thousands of other planet types await discovery. NASA's James Webb Space Telescope is at the forefront of these efforts, unveiling cosmic secrets with each passing day. This incredible observatory continues to gather detailed data and stunning pictures that shed light on phenomena we previously could only theorize about. Recently, it made a groundbreaking discovery: the first clear detection of carbon dioxide in an exoplanet's atmosphere. This planet, 700 light-years away, revolves around a sun-like star. The discovery provides vital clues about its chemical makeup and evolution. It marks a major milestone in our search for life on other planets. NASA Administrator Bill Nelson emphasized that this finding offers an entirely new view of the universe, generating excitement all over the global scientific community. And there's more. The James Webb Space Telescope has captured spectacular infrared images of the cosmos. In one case, it observed the object known as IRS 110-4, which illuminates a cloud of cool, wispy material behind it. Orange hues mark the glow of distant stars, hidden behind layers of ice and dust. This research is part of the Ice Age initiative, an investigation into the formation of ice in space, from interstellar grains to icy comets. Additionally, the telescope has, for the first time, imaged the structure of a dusty disk surrounding a nearby red dwarf star in the infrared spectrum.